The absolute value of a number a, denoted with a inside these vertical bars, is just representing the distance that a is from 0 on the number line. Now, because absolute value is representing a distance, then we would say that it is always non-negative. Non-negative. It's not quite as precise to say that it's always positive because a could be greater than or equal to 0. So because it could be equal to 0, 0 is neither positive or negative. So we just say that it's non-negative. So if we think about the absolute value as a function, right, with inputs and outputs, we can define the absolute value as a piecewise equation. So if we consider values for the input that are greater than or equal to 0, right? So if we're looking at the absolute value equation, absolute value function. So consider things that are going into our equation with a value that are greater than or equal to 0. Let's say something like the absolute value of 7. The absolute value of 7 is 7. 7 is 7 units away from 0. So if we're looking at values that are greater than or equal to 0, the input and the output end up being exactly the same. I get out exactly the same thing that I put into my function. So for values of x greater than or equal to 0, my output is just going to be the same as my input. But if we consider something like negative 1.3, numbers less than 0, the absolute value of negative 1.3 is positive 1.3. Negative 1.3 is 1.3 units to the left of 0, but its distance is 1.3. So in this situation, when a value is less than 0, we're going to get out the opposite value. So instead of just getting out the input, we get out the opposite of our input. And so this right here, this definition, is what we can use when trying to talk about absolute value in a piecewise equation.